told you that there is a way that we can predict the inevitable end of the universe. Really? To answer that, we must know what is entropy.
In thermodynamics, entropy is a measure of disorder in a system. Let's measure it with this simple example. There are 5 marbles, our molecules, inside each glass, one of which is significantly smaller than the other. As you can see, the molecules in glass A have less room to move. The space in glass B, on the other hand, is way greater. This means with more space for molecules to move freely, the more probable the molecules will be disordered, like glass B, and hence have more entropy.
This natural tendency to increase entropy over time is described in the second law of thermodynamics. According to this law, the entropy of an isolated system never decreases, implying that the system will continue the thermodynamic equilibrium on its own. To put it in another way, this ice cube, due to their restricted water molecules, will move from a state of lesser entropy to a state of greater entropy. This is because of the heat energy that disperses molecules. As a result, this produces an overall increase of the system of entropy. However, heat cannot transfer energy spontaneously the other way around. But it's still possible. For instance, if the system's entropy drops, it may be necessary to combine various processes or employ an external force in order to maintain the overall increase of entropy. Like
how a hot water if placed on a freezer will quickly cool. But in order to maintain the decrease in entropy inside the freezer, the refrigerator will release heat, causing its environment to rise in entropy. In other words, unless external forces are used to work things out, entropy will always increase to reach equilibrium. Now that we've learned entropy, you might ask, how did it relate to the end of the universe? Everything! In fact, the answer has already been given more than once. Have you figured it out? Have you noticed how the table is becoming increasingly disorderly as time passes? You did? Awesome! Well, we first learned that isolated system with a large quantity of entropy tends to lose order. Then we discovered that entropy increases with time. And finally, we learned that entropy strives for equilibrium. This important concept we learned showed us that as universe, an isolated system will soon enough suffer and reach a state of thermal equilibrium or the heat death of the universe. Fortunately, that will not happen anytime soon. Until then, I'll try to be the external force to help her clean up.